Hello, I'm gonna go through some of the questions on the practice exams that we went over already in class. The questions just asking to compare the pairs of compounds in front of us, and it's gonna be one of either of these things. So it's either gonna be an enantiomer, a diastereomer, constitutional isomer, the same compound, or different compound. I'm going to try to do one of each. And just how I learned it in class from reading the textbook and from any tips and tricks that I've like picked up from other videos that have helped me, I will also share. And then you could just do whatever works for you best. If whatever I show is like more confusing, just like completely ignore it. Okay, so we're gonna start with this. I always start by numbering the parent chain. And so that's what I'm gonna do. I'm gonna do one, two, and you can go all the way around if you'd like. Once I hit all the substituents, I don't think it's helpful to continue going. And then one, two, we have an OH here, we have a chloride on number one. Okay, next, OH on number two, bromide on number two. So these compounds don't even have the same molecules making them up. So this is entirely two different compounds that we cannot continue to compare. So we're going to just write different compounds. Cool. So let's go to the bottom. Here, there's nothing really to number, especially since you have the Newman projection. So what we're going to do instead is these are already like two chiral centers, we're going to assume. And so we're going to find our chiral centers here, and we're going to just check and see if the same molecules are bounded to this middle carbon here that are also bounded here. And if they're different, then we can continue going forward. So we have OH, bromide, methyl. Here we have OH bromide methyl. Okay, so far they're the same. On the second carbon, it's an amine, an ethyl, and then when there's nothing there, we assume hydrogen because carbons have to have four bonds to be stable. And so we're going to check here, amine, ethyl, hydrogen. Nice. So now immediately we can write these are not different. And then we can also, usually once you're checking this off, you can almost immediately tell if the connectivity is different. Like if instead of here, the OH, they have like the ethyl and like the OH is on the other one, then the connectivity is different. Even though these two compounds are made up of the same molecules, their connections might be different. But from here, we can tell that they have also the same connections. So we're going to just write not constitutional or not cons. Okay. Then the next thing we want to do is figure out, are these the same? And the quickest way to do that is to assign R and S configurations for each chiral center. And so let's assume this is our first one, and we're going to take a look at it. We're going to do prioritizing or assigning numbers to these based off of their atomic number. So bromide here is going to be our first priority because it has a larger atomic number. This is directly connected to oxygen, which is going to be our second priority. Then we have two carbons here. And once we're comparing two carbons, we move on to what they're connected to. This one's going to be connected to an H, an H, and an H. And then this one's going to be connected to an amine, an ethyl, and an H. Well, the nitrogen. And so automatically we're comparing a nitrogen, another carbon, and a hydrogen. And these already go off. And so we're going to know this one's going to be our third, and this one's going to be our fourth. And so when it's like this, though, I know usually like we started learning that number four is almost like always the hydrogen if it's available. But if there's no hydrogen available here, we're gonna keep number four as the lowest priority group, which is the methyl group. However, because it's our lowest priority group, it should be in the same spot as this dashed line. It should be like facing away from us. And so if we're looking at this, 1, 2, 3, it is looking like it's going counterclockwise. It's looking like an S direction. And so we can try to visualize what it would look like if this was in the back. There's two ways you can do this. The first way is you can build it. Actually, there's three ways. The first way is you can build a model if you have a kit right there on the exam table. If you do that, I recommend just come in already having like a butane set up and like ready to go and just attach the end pieces. That way you're not like putting together like 6, 7, 8 different pieces during the exam. But that's the first way. If you don't have a kit, the next way I learned from the textbook is you find the lowest priority group, which is 4, and then you look for which number has those dashes that we want. Number 2. So that one, we want our 4 to be where that number 2 is. So the textbook suggests to just switch their numbers. We're going to make this 2 now. We're going to make this 4. And it's not just switching their numbers. This will also go down here, and then this will be our new methyl. And then what's remaining, you just switch those numbers too. And then you have the 3 here and the 1 here. And same thing, the bromide would also move. You're trying to visualize it being turned around. And then this will be our carbon that's connected to our thing here. So now we've rearranged it, and now we have 1, 2, 3 going clockwise, the opposite direction. So that's going to give us our configuration. That's one way to do it. Another way to do it, if that's too confusing, it usually always works for me to just switch the numbers around, even if I don't need to switch the letters around or like the molecules, I can just be able to flip around that configuration real quick. Another way to do it now, let's go back and write down which one was our, oh, okay, which one was our number 1, our number 2, right? And then this one was number 3. What is happening? What on earth? Hold on. Okay, this is lagging so badly. Okay, I don't know how that happened, but I think we're good. So I'm just going to continue writing over those things. This is our number 1, our number 2, our 3, and our 4. Another way to do it is, okay, from this point of view, it's looking clockwise S. We know that's wrong because this should be facing the back. I saw on a video somewhere, I can't find that video, is you can rotate your paper, like the professor said, or you can just draw a stick figure person, right? This is where a person would need to be to look at this molecule from this direction, or assuming it's 3D, so that 4 is facing away from this person. We agree? And now it's just like a matter of perspective. What do you think this person is seeing? This person is definitely seeing a 1 on their left. They're seeing, oops, they're seeing a 1 on their left. They're going to see the 2 on their right. This thing is lagging. They're going to see the 2 on their right. Then they're going to look down and see the 4 on their bottom right. And then underneath their 1, they're going to see the 3. That's what this person is seeing. And so if we look at it, it's clockwise, which is also R. So this helped me so much, just like drawing a little doodle instead of turning my paper around. And I know this 4 is facing away from him, so he's seeing it the right way. Okay. And then we can go on and compare the one on this side. Okay, so we have 1 again, and then our 2 was the oxygen. Our 3 was connected to this carbon. That carbon is the center carbon. And then our 4 was out here. So this is like a little awkward now because we're looking at this and we're like, okay, is this also clockwise? Again, you want to do it in a way where the CH group or the methyl group is facing away from you. So now, how would this face away from someone? Well, this person is going to be standing, there's a person standing right here, a little stick figure, and he's looking at it from this perspective. That's his laser vision. Let's see what he sees. On his left, he sees first thing on the top is a 2. And then like on his like lower right, it looks like he's seeing a 1. And then like right beneath the 2 almost, he's seeing like a 3. And the 4 is facing away from him, which is like all the way back there. So what he is seeing is 1, 2, 3 counterclockwise. So it looks very different again from what we're seeing. So his version is correct because he has the methyl group facing away from him. So this one is counterclockwise S. Right off the bat now, this is an S and this is an R. They're not the same compound. So we can knock that out because they were the same compound. They'd have the same configurations. However, what could it be now? It could be either a diastereomer or an enantiomer. And if it's an enantiomer, every single letter here will be the opposite found here. If it's a diastereomer, the order is not opposite. It'll be like S, R, and then it'll be like R, R, and it's like, it's not matching up. So now we have to find the second one here. And so let's start labeling our priority groups or our priorities. Nitrogen here is number 1. Second one can't be hydrogen. We know that one's going to be number 4. So this is where it gets tricky. Let's actually just switch colors because hopefully on the pen on the exam you can bring like a multicolored pen thing. Let's switch colors because we don't want to. This is I always do with pencil, and then like I'll draw 3 or 4 or 2 here, and then like I mix up these numbers with these numbers. Those numbers belong to this group. So I'm going to go here with 1, and then we know this one's 4. Now, which one's 2 and which one's 3? We have a carbon here and a carbon here. This carbon we know is going to just be connected to like 2 hydrogens and another carbon. So it's going to be CHH. This carbon is connected to like bigger atoms. And so we know this one's automatically going to be number 2. And now we can put this one as number 3. So look at that. H is already dashed here. So we can assume this is facing away from us, and this, what we're seeing, is the correct perspective. So let's look at it. 1, 2, 3. This is going clockwise. So now we know this one is R. Now, let's look at this one. If this one ends up also being an S, these are enantiomers because each one is opposite of the other. If this one ends up being an R, the entire thing automatically is discounted, and these are just diastereomers. They're compounds with like different configurations. Okay, so let's look at this one now. So we have our 1 here. We have our 2 is in the middle, right? Because 2 is connected to the other carbon. Our 3 was the ethyl group from this side. That real quick. And then our 4 was the hydrogen. And we know our hydrogen was facing away from us. It should still be facing away from us. So we know this is set. So let's go ahead and do it. 1, 2, 3. That's counterclockwise. This configuration is an S. So S, opposite is R. S, the other one is R. These are complete opposites, so we know they're not diastomers. Not dia. Oh, this is getting really laggy. I'll end it after this one and make another video. And so we know these are N and T polymers. There we go. Nice. All right. So that's it for these things. The person really helps me do it. If you can get a kit, get a kit. Oh, something else I wanted to show you too is like we're basically supposed to be seeing this. This is just like an RRS configuration. We're R4, when they say dashed, if it's dashed, it should always be facing away. But let's look at the numbers really quick on this. So with the 4 facing away, the 1 is on the bottom left, 2 is on the right, 3 is on the top. However, if we flip it completely, this is going 1, 2, 3, this is going S. But if we make that 4 face us and it's like a wedge, then the 1, 2, 3 is going in our configuration. So that's like what we're trying to do on like 2D paper, which is really hard. And that's why you should find whatever tips and tricks will work for you to be able to see the different perspectives. But okay,